Thank you for tuning in to Bear's LeetCode grind. Today, we're going to be going over an easy problem, the Roman to integer calculation and conversion. The problem statement is given a Roman numeral, convert it to an integer. To summarize, Roman numerals are represented by 7 different symbols, I, V, X, L, C, D, and M, with their respective symbols and values here. And here's how to calculate. You merely add them up. The edge case that we need to worry about is given these subtraction cases. For instance, writing 4 is not I, it's IV. And the 1 is before the 5. We subtract it, making 4. Same principle applies to 9. And there are 6 instances where the subtraction is used. I can be placed before V and X to make 4 and 9. X can be placed before L and C to make 40 and 90. And C can be placed before D and M to make 400 and 900. So the first thing that you should note in this problem is you are given a set of symbols and key values. Now, what would you want to store this in? Not an array, not a linked list, not any of those data structures. You want ease of access for a given key to get the value, which is a map. So, step 1, store the Roman numerals and their respective integer values within a hash map for easy access and lookup. So once we store these values into a hash map, we can easily access them. Now, in order to solve this, the next step would be iteration. Iterate over the string S, character by character, and sum the Roman numeral to integer values. Return the sum. That'll work if everything's positive. If you have a subtraction case, which is the edge case that we need to be wary of, this will not work. So, in order to accomplish looking at the entire string of characters of Roman numerals and summing the entire string, we have to also check and see if it could be a subtraction case. Now, in order to check if it's a subtraction case, we're going to need to keep a pointer on the current character, the current Roman numeral, and keep a pointer on the next Roman numeral if it exists. So, step 3, edge case, subtraction case. Keep a pointer at the current Roman numeral and next Roman numeral if current Roman numeral is less than next Roman numeral, subtract the current Roman numeral from the sum, and process next. So to give an example, let's say we had IV. So to visualize this, you're given IV. You've stored all the Roman numerals and you're iterating over it one by one. I equals 1. You're looking that up in the hash map. And the next pointer is V. V equals 5. So I is less than v sum equals -1. Then you process the next character, v. Next equals null. So we're going to have to account for a null check. Otherwise, we'll get null pointers from processing this. Current equals 5. Next is null. So now we just add sum equals 4, which is the correct answer. So let's go ahead and program this. Step 1, store the Roman numerals in the hash map. That is easy enough. We're just going to do basic map. Map of character and integer, as the maps need the primitive classes here. Roman int map equals, and you can use the map.of method to assign this map in place so we don't have to create it and then populate the fields with like a put operation, just a little cleaner. So we'll put in all the Roman numerals here. And it is case sensitive. So make sure they're capitalized. I, V, X will be 10. L will be 50. C will be 100 century. D will be 500. And M will be 1000. So our map's created. Now let's create our return result, return variable. We'll assign it to 0, as we haven't calculated anything. And now iterate over the string, return the sum, and calculate or count for the edge cases. To save calculations, we'll go ahead and create a length that way we don't have to continuously run this calculation and loop over the string. We'll just save a little bit of speed. For int I equals 0, I is less than length, I plus plus. Int current Roman equals the Roman int map dot get the character at the index I. And now we want to check and see if it has a next pointer, another character afterwards. And if so, we want to compare the current with the next. And if the next is greater than, then we will subtract. First, we want to make sure it's there. So if I plus 1 is less than length, then we have another character. And if the current Roman is less than the next, then sum minus equals current Roman. Otherwise, sum plus equals the current Roman. Straightforward enough. And here we're at the end of the method, so we will return our sum. And this should work. And it is accepted. So you can see here. Also, we'll submit it. And success. Beats complexity. Could be a little bit more efficient if we cycle through from the right to the left, I believe. So just to summarize this problem, our main things to note were, one, identifying the data structure to hold the parameters of the problem, which is a hash map, because we were given a key value pair. And then number two is to just iterate over the Roman numerals. And then number three is the edge case for the subtraction. We need to account for that. So we will compare the next with the current. And if the next is greater than the current, then we subtract the current. Otherwise, merely add it. And in that process as well, we also want to do this with avoiding a null pointer exception, which is why I am doing this statement here, I plus 1 is less than length. Because if it is greater than the length, then we are going to get a null pointer exception and out of bounds error. So that covers there. And then we merely are just checking to see if the current is less than the next. And yeah, that is Roman numerals to integers. All right, so if you're here, then you just finished the Roman to integer. And now you're curious how you can make it more efficient in terms of speed and space and time complexity, basically. So let's look at this again. In our prior solution, we used a hash map in order to store all these values, and then iterated from left to right in order to get the calculation of the sum. So let's think about how we can make this more efficient. Can we use a different data structure than a hash map? Hash map has overhead. Using a hash map for lookups, it hashes the key and retrieves the value, which has a time complexity of O of 1, but it has additional overhead for hash computation and table management. So one thing we could use is a switch. A switch statement could directly map the characters to integer values, eliminating the need for a lookup structure. The performance is constant time, O of 1. It's the same time for lookup, but it has no extra overhead. And if you combine the logic into the switch statement, then it's very short and easy to read, and you don't need any data structures. Hash map requires additional memory to store key value pairs, so that's not necessarily the best. Whereas a switch statement is solely based off the program's control flow and doesn't use any memory. So I think a switch statement would be best. Now, we were iterating from left to right. If we were to iterate from right to left, then we wouldn't need to do the next character check. It would be a little bit finicky. So that logic would require comparing the current numerals value with the previously processed numerals value, making it more efficient. So let's start it. One thing to note is right here. This is going to be the fun computation in logic. How can we iterate from right to left? For instance, VIV, we iterate from right to left. How can we get 4 without checking that character? So Roman numerals, subtraction happens when the smaller numeral, like I, is before a larger numeral like V. Now, subtractive pairs in Roman numerals are designed so the smallest numeral is at the most 1/5 of the larger number. So I before V or X before L. You can see 1/5. So let's program this out. First, going to give our return variables. And now we're going to begin the switch iteration. So for int I equals the string's length minus 1, because string's length gives you the length, not based off 0 index. So we want to get the length, move it to 0. And then we're also going to be checking to see if I is greater than or equal to 0, because we want to go all the way to the left. And we're going to be iterating from the right, so we're going to be subtracting from I. And now we start the switch. So we're going to build the switch case for each one of the Roman numerals that we have. So I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. So we'll go ahead and put these values in here. L is 50, X is 10, and V is 5. So right here, what we're doing is we're iterating from the right to left, and whatever character we get. So let's do IV, for instance, as an example. So we iterate starting here. It is a V, so the current number equals 5, and we break out. Now, since Roman numerals are, since the subtractive cases occur when the current numeral is smaller than the total answer, we're going to be checking for 1/5 of the numeral. So we can do that by multiplying 4 times the current number. And if 4 times the current number is less than answer, then we don't have to compare the numeral pairs. So if 4, so for instance, I equals 1, V equals 5, and this would be the logic. If 4 times current number is less than answer, subtract number from the answer. Otherwise, add it. So we can test this out just in pseudocode here. So we have IV. We're iterating from the right. So V times 4 20 and is 20 less than answer? No. So we add it. Now we're iterating on I. So current number equals I equals 1. Answer equals 5. 4 times the current number so is 4 less than answer? Yes, 4 is less than 5. So we subtract it. And that's correct. So hopefully that makes sense. So let's program it. Else we merely add it. Now, hopefully this works. I have I'm missing a return statement here. Oopsie daisy. Let's try it again. And it's accepted. Passed. You can see here. Passed as well. Submit. And we are faster than 100% of people. And so, to summarize this approach, instead of using a hash map, which is O of 1 access speed, we are worried about the overhead for computing the hash key and the pretty much maintaining the map itself. So we're using a switch statement, which does it in line, so it's more efficient, doesn't utilize as much memory. And we're also iterating from right to left because we don't need to check the next value if we do this. And we're using 4 times the current number in order to calculate the value because all the Roman numerals are 1/5 of the size in a subtraction case. So if you multiply 4 times it and it is less than, then you can be sure that it is a subtraction case. And doing so gives us a lot faster run through and much more efficient. And that's all for this one.